Welcome to lesson 7.4, equations in quadratic form. Today we're going to do a number of examples. So what I notice here is that this 3x minus 2 is repeated, once with a square and once without. So this sort of looks like a quadratic, and it'll look much more like a quadratic if we get rid of this 3x minus 2 and replace it with some other variable. Let's say y. Then what I'll see is that instead of 3x minus 2, I'll have y. So y squared minus 5y minus 6 is 0. And now this is a quadratic that we know how to solve. We'll try factoring because that's fastest if it factors. So I'm looking for numbers that multiply to negative 6. So I'll have a negative and a positive and add to 5, negative 5. 6 and 1 will do that. So this factors as y minus 6, y plus 1, equaling 0. So if y minus 6 is 0, then y must have been 6. And if y plus 1 is 0, then y must have been negative 1. But we weren't really looking for y. We were looking for this x. So let's go back and replace our y with 3x minus 2. So 3x minus 2 is 6, or 3x minus 2 is negative 1. In each case, I will add 2 to both sides and then divide both sides by 3. And so now I find my final answers for x are 1/3 and 8/3. Let's do another example. Again, I see that I have this 1/2x repeated, once with a square, once without. So I'm going to do the same thing I did before. I'm going to replace them with a new variable. And once I've done that replacement, I see, hey, look, we just solved this problem. So I can jump to my solutions for y. And then replace my y with the thing I'm really trying to find. If I multiply by 2x on each side, and then divide by the number in front, I now have my answers. X could be negative 1/2 or positive 1/12. Let's try it again. Here, it doesn't look like a square, but if you notice, x squared, when you square it, gets me to x to the 4th. So if I let my y be x squared, then y squared would be x to the 4th. So let's do that. X to the 4th, that's y squared. X squared, that's y. And now, again, we're going to try and factor. So multiplying to a negative, I'll have a negative and a positive. Adding up to 7, looks like we have negative 2 and positive 9. So now if y minus 2 is 0, then y is 2. If y plus 9 is 0, then y is negative 9. And again, we weren't looking for y, we were looking for x. So I'm going to replace y with x squared. And when I take the root on both sides, I'll find that x is plus or minus the root of 2, or x is plus or minus the root of 3i, the root of negative 9, which is 3i. So I find my answers for x are plus minus the root of 2, or plus minus 3i. Let's try examples 4 and 5, which have roots in them. So, in example 4, let's try this new method of replacing the root. So if I let my y be root x, then y squared would be x. If I do this replacement, 3y squared minus y minus 10 is 0. I can try solving by factoring. Remember, when there's a number up front, this is not just that number, it's these numbers multiplied together. So again, I'm looking for something that multiplies to negative 30, adds up to negative 1. So I'll have a negative and a positive. In this case, 6 and 5. Now this does not give us our final answers. This is how we're going to split the middle term. And then I'll treat each piece separately. So from the first pair, I can pull out 3y. From the second pair, I can pull out 5. And now I see my y minus 2's match, so I can pull that out as my greatest common factor. And I have factored this. So if y minus 2 is 0, then y equals 2. If 3y plus 5 equals 0, then y is negative 5 over 3. Again, we weren't looking for y, we're looking for x. So I get that root x is 2, or root x is negative 5/3. So, squaring both sides, I get that x is 4, or x is 25/9. So, remember that because we squared both sides, I need to check my answers. So let's check 4. 3 times 4 is 12, minus the root of 4, 2 minus 10. 12 minus 2 is 10, minus another 10 is 0. That worked out. For x is 25/9. 25/9 times 3 is going to get me 25/3. The root of 25/9 is 5/3. 25 minus 5 is 20/3, which is not 10, so this is not going to be 0. So my final answer is that x is 4. Now, if you'll recall from chapter 6, this is not the only way to solve a problem like this. I could have used the method from chapter 6, which would be to get that square root away to the other side. Then I would square both sides. Remember not to miss that middle term when I'm squaring. Subtract x to set this equal to 0. Now if I try factoring, I'm looking for numbers that multiply to 900, add up to negative 61, so they'll both be negative. Let's see, possibilities. We could have 109, well that's not going to get me 61. 90 and 10, definitely not. 60 and 15, that'll get me 75, I'm getting closer. 25 would give me 36, and yes, that gets me to 61. So I have 36 and 25. So 9x squared minus 36x minus 25x plus 100 is 0. I can factor out from here a 9x and I can factor out from here a negative 25. So I'll get 9x minus 25 times x minus 4 equals 0. So either x is 25/9 or x is 4. And if we look again at our check, which we must do because we squared both sides in this first step, 25/9 does not work. And we find that x equals 4. So if you notice, the amount of work I did in each procedure is about the same, but the actual factoring work that I had to do in this case was quite a bit simpler in the numbers that I got than the factoring work I did using the method from chapter 6. So when you get something like this that factors easily, then this new method of replacing your root x with a new variable will be faster and easier if you get something that looks quadratic. Let's try it again. So, in example 4, again, I can let my y be root x, which will mean that y squared is x. So I can replace my x with y squared, and I can replace my root x with y. And now, again, I try and factor minus 6 plus 4, so it'll be a negative and a positive. Let's see, my possibilities to multiply to 6 are 1 and 6, or 2 and 3. Minus 1 plus 6 will get me to 5. Minus 2 plus 3 will get me to 1. So this does not factor. So this is not going to be useful. But it's okay if it doesn't factor. I still know how to solve this. I could, for example, apply the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over twice a. So I'm going to get negative 4 plus or minus the root of 16 plus 24, which is negative 4 plus or minus the root of 40 over 6. The root of 40 simplifies. There's a 4, which is a perfect square sitting inside. So I can pull that out. And now I notice that all these pieces are even, so I can divide top and bottom of this fraction by 2. Okay. But remember, this was my y value. I still have not found x. So I could have root x being negative 2 minus root 10 over 3, or the root of x is negative 2 plus root 10 over 3. And again, I will solve by squaring both sides, which means I have to check my answer when I'm done. Squaring both sides here. When I square this out, remember not to forget your middle term, so I'll get 4 plus 4 roots of 10 plus 10 all over 3, or in this case, I will get 4 minus 4 roots of 10 plus 10 all over 3. So in this case, 4 plus 10 is 14. Could be plus 4 roots of 10 or minus 4 roots of 10. All over, and I have made a mistake because 3 here should not have remained there. I'm squaring, so I should be getting 9 in each of these cases. So there are my possible answers for x. If I wanted, I would have to plug these in. When it's this complicated, I would suggest grabbing your calculator and plugging them in on your calculator. Let's try the negative one for the minus piece first. So if I do 14 minus 4 roots of 10, let's see what that is. 1.35. This might work out. So that number divided by 9 is going to give me this decimal. And let's try plugging that in. So 3 times my answer plus 4 times the root of that answer minus 2. And I do get 0, so that negative answer will work. Let's try again. So my numerator 14 now plus 4 roots of 10. Close my numerator, divided by 9. Gets me this number. And then I will do 3 times that answer plus 4 roots of that answer minus 2 does not get me 0. So what have I learned? The correct answer here is the one with minus. And that is the final answer. Now, this was a bit complicated with the quadratic formula. So let's see what happens if instead we work it out using the method from chapter 6. So again, I'm going to move the stuff with the root to the other side. So I'll get 3x minus 2 is negative 4 root x. When I square, don't forget that middle term. I'll subtract the 16x from both sides. And if this didn't factor, this is not going to factor either. So I'm going to go straight to the quadratic formula from here. So negative b will be positive 28 plus or minus the square root of whatever 28 squared is, minus 4 times 9 times 4, all over twice 9, which is 18. Let's figure out that root on our calculator. I got 640. Okay. The root of 640. Well, 640 is divisible by 16. Is it divisible by something better than that? So 640, 16 is a perfect square. Well, 64 is a perfect square. It's 8 squared. So let's pull that out. And it looks like all of these numbers are divisible by 2. So I will get 14 plus or minus 4 root 10 all over 9, which should surprise nobody because that was the answer we got over here. And then again, because we squared both sides, we're going to have to plug that in and see if we get 0. And we learned in the previous working that the minus answer was the one that worked out. So now if we look at this work, we see that the method from chapter 6 was actually much faster and easier. And that's the case because we got something that didn't factor over here.